Solving linear equations in one variable. Just going to give you a general guideline to go by. Here's some explanations of what I'm going to be doing. The first step, possible steps, are just cleanup steps, trying to make the problem as short as possible, as soon as possible. The next couple of steps are all used to isolate the variable on one side of the equal sign. When it says solve, all that means is isolate the variable on one side of the equals. Does not matter which side. So let's look at some of these examples, just to give you an idea of how this process is done. When I see this problem right here, I see that there are x's, or x terms on both sides, and constants. Constants are numbers that do not have variables. So I have constants on both sides. Now, when I look at this, I can't combine the 7x and the 12. They're not like terms. I can't combine the 3x and the 8. They're not like terms. It would be nice if I had the 7x and the 3x on the same side, so I could combine those. It'd be nice to have the 12 and the 8 on the same side, so I could combine those, but I don't. So what I'm going to do is, I'm going to add and subtract terms to where I have the x terms on one side and the numbers on the other. Now, it does not matter where you begin, but a good suggestion to go with is to start with the x's. Always begin with the x's, or the y's, wherever they may be, in this case the x's, and eliminate the smaller of the two, or the three, depending on what you have. So on this one, I'm going to eliminate the 3x first. When I look at that, that's 3x plus 8. So that 3x is being added. Furthermore, that 3x is a positive 3x. So I'm going to think, if I want to eliminate the 3x, that's a positive, what do I do? Well, I think the opposite. The opposite of a plus 3x is a minus 3x. Now, a positive and a plus is the same. A negative and subtract is the same. So if I have a plus 3x, I'm going to subtract 3x. And the rule of solving equations is, what you do to one side, you must do to the other. So that's why I'm going to subtract 3x on this left side also. Now I'm going to work on this side because that's where I started. These 3x give us 0x, which means they eliminate because we're not worried about 0 so much. And then, even if we are, if you want to, you just think 0 plus 8 is 8. Now over here we have 7x minus 3x because these are our like terms. And it leaves us with 4x. Now that plus 12 isn't a like term because it doesn't have an x, so we just bring it down. What we've done is we put all the x's on one side and we combined them, which means we now have fewer x terms. And in fact, we only have one x term, which means we're getting closer and closer to the goal, which is to isolate the x. Next thing we want to do is get rid of the 12. We want it away from the x term, and plus we want this over here with this other constant so we can combine them together. Now, everything's saying eliminate the plus 12. So think opposite. What's the opposite of plus 12? Minus 12. Well, what should you do to one side? Let's do the other. So we'll subtract 12 from the right side also. These give us 0, which leaves the 4x. 8 minus 12 gives us negative 4. And as you can tell, we're getting closer and closer to the ultimate goal of having an x all by itself. In order to achieve the final goal of getting the x all by itself, we need to eliminate the 4 in front of the x. Now when you read that, that's 4 times x. To eliminate the 4 being multiplied, think the opposite. It's actually the inverse, but we'll call it the opposite. The opposite of 4 is, or multiplying by 4 is dividing by the 4. And the reason why you want to divide by the 4 is because 4x divided by 4 leaves you with the 1x, and 1 times x is the same as x. So in other words, these 4's will cancel, leaving a 1, and 1 times x is x. That's what we're trying to get to, an x all by itself. But the rule is, if you divide one side by 4, you must divide the other side by 4. So negative 4 divided by 4 is negative 1, and we have just completed the problem. Anytime you get the x by itself, or whatever the variable may be, a positive variable that is, you're done. So let's do a few more, give you an idea of what's going on. Look at this example. I want the x's on the same side, the constants on the other. I'm going to always start with the x's. It's a good rule to go by. You'll save yourself a lot of headaches if you do that. Get rid of the 2x because it's smaller than the plus 5x. And we're going to think the opposite of 2x, which is a negative 2x, or subtract 2x. And what you do to one side, do to the other. These become 0, leaving the negative 9. Don't forget that minus sign in front of the 9. It stays with it. And then over here we have the 8, and then 5x minus 2x is a positive 3x. we got x over here. We got constants on opposite sides, so we need to put those on the same side. We don't want the x over here because we're trying to get this 3x by itself, so we're going to subtract the 8, because it's a positive 8, from this side and also from this side. What's going to happen when we do that, these 8's will cancel, leaving only the 3x. These will combine together, become a negative 17. When you do these over and over again, you're going to see that you're going to almost always have x term on one side and a number on the other. In fact, it will always be that case if you do it correctly. If you're solving these types of equations, that is. Now, once again, the last thing to do is get the x by itself. That's 3 times, so we're going to use division. Let's do one side, do the other, and we have just completed the problem. Once we have x by itself, we're done. Now, this next problem has parentheses. What we're going to do is we're going to eliminate the parentheses first by using the distributive property. Now, it'd be nice if we could combine the two terms together inside, but we can't. They're not like terms. Over here, they're not like terms either. So we're going to distribute the 6 to the a. We get 6a. Take 6 times the negative 5, which is negative 30. Since the parentheses close, I'm done distributing the 6. Write down the equals. Do the same thing with the 4. 4 times a and 4 times 1. 4 times a is 4a. 4 times 1 is 4. Now we're back to the same old, same old. I'm going to start with the smaller variable term, which is a 4a. I'm going to subtract it from both sides. Over here, we're going to get 2a minus 30. Over here, only the 4 remains. What we're going to do now is we're going to isolate the a term by adding 30 to both sides. These will become 0, which leaves 2a. Over here on the right side, we're going to get 34. And the last step is to isolate the a by dividing, because it's 2 times, so we're going to divide by 2 on both sides. Those will cancel, leaving a. And 34 divided by 2 is 17. Let's do another one. Once again, we have parentheses. We're going to distribute the 4. Take 4 times x and we get 4x. Take 4 times 3 and we get 12. Bring down the 12 on the right side. We only have one x term, so we're not going to worry about that one. We're going to try to isolate it by eliminating the plus 12. The 12 is being added, so we will subtract. Once you do one side, do the other. Those become 0, leaving 4x. 12 minus 12 is also 0. A lot of people have a hard time believing that you can have a 0 up here. Yes, you can. The last step is to isolate the x. Since that's 4 times x, we're going to divide by the 4 to both sides. And 0 divided by any number that's not 0 is 0. And yes, it is true, you can have an answer of 0. So don't be afraid of that. That may happen more often than you might think. And these are just some examples, basic examples. It gives you a good idea of what to expect. The last thing we're going to look at, we're going to do a translation problem. Hopefully you've seen some other videos that I've created that talk about sum as being add, differences subtract, product multiply, quotients divide. Some new thing that you might see is the word is. Anytime you see the word is, it means equals. There are other ones, but that's the most common one. So all we're going to do is just translate this into an equation. An equation, first 4 letters are short for equals. Somewhere you're probably going to have an equal sign in there. So here we go. We'll take this word for word, the product. Product means multiply. Have 3 and the sum. So you get 3 and the sum is plus, and then negative 9 and 11 is means equals 6. Somehow we have to make an equation using this information. Let's start at the beginning. We have the product of 3. What that means is you got to take 3 times something. Now we have product of 3 and the sum. Well, the next thing I see is a plus, but I don't want to write a plus there because it doesn't make any sense to have a times and a plus side by side. So what that must mean is I got to find the sum of something before I can multiply it by 3. Well, I need to find the sum of what the problem says, which is negative 9 and 11. So the sum of negative 9 and 11 will be written as negative 9 plus 11, and then is equals, and then 6. Now, the way it's written isn't correct, because if I were to do it by the order of operations, I would multiply first. 3 times negative 9 is negative 27. Negative 27 plus 11 is negative 16, which definitely isn't 6. So, we have to look at this a little bit more closely. We're taking the product of 3 and the sum, which means we're taking the sum, or 3 times the sum of these two numbers. What that really means is, I need to find the sum of these two numbers first, and then multiply that answer by 3 to have a true statement. The one way to guarantee that we take the sum of these first before we multiply is parentheses. Always be aware that parentheses can be really helpful in problems like this. And the reason why we have to have parentheses, not only because of the wording, because that's the only way we can get a 6. Because by the order of operations, you do parentheses first. Negative 9 plus 11 is 2, and 2 times 3 is 6. So therefore, with the parentheses, it does check out.